Alright. Hopefully everything's working fine. Yeah, seems like everything's working fine. Audio maybe is a little bit quiet, I don't know. Might be. Anyhow, we're gonna go over chapter 5 now. We're gonna start with data analysis. This is a part that I don't remember. I remember some of it, but a lot of it I don't remember. So, we're gonna go over data analysis. Candidates should be able to do these things: present and interpret data in tables, understand the meaning of measure of central tendency, name, recognize, and know how to find measures of central tendency. For example, mode, median, and mean. You won't have to learn how to calculate these. You have to understand the meaning of measure of spread. So I'll be writing this down. So data this tables, measure of central tendency, find measures of central tendency. We have mode, mean, I wrote it in the wrong order, but it's fine, and median. And then we have measure of spread. Name, recognize, and know how to find the range. Standard deviation. You have these ideas here. There's another space in between. Graphs / charts. You have a bar chart, a histogram, and a scatter graph. Cool. And finally, candidates will not be required to carry out any calculations, thank God, because we all know we picked psychology because we don't want to do math, and candidates will not be required to understand or interpret statistical tests or findings other than as specified here. So, let's go over this, shall we? Boom, there you go. So, we actually start by not talking about tables at all. So, I don't know what the, I don't know what they were smoking. It must have been good when they made that syllabus. So, measures of central tendency. Measures of central tendency are descriptive statistics along with measures of spread. They help researchers to summarize large sets of individual data points so that trends and patterns can be identified. Measures of central tendency summarize all the data into a single score, which tells us tells us about the midpoint or average score. In an experiment, a researcher wants to know whether there is a difference between the results of an experimental and control group. To do this, they will compare the average results of the two groups to see whether there is a difference and how big that difference is. Altogether, there are 3 measures of central tendency: the mean, median, and mode. So they are descriptive. Oh, had a caps lock on. Measures of central tendency. Descriptive. Wow, I can't spell. Maybe I can type more like statistics. Summarize large sets of data points. Single / patterns / numbers. Um, allows for easier comparison of variables. Very nice. Okay, so now find measures of central tendency. The mode. The mode is the most frequently occurring point. The most frequently occurring data point. So what that would look like is, what's a good example here that we can do? So if you've never heard of this before, which would be kind of surprising, but if you've never heard of this before, let's say, let's say we did an experiment where everybody rated how good a banana tastes, okay? Just a random banana. They rated it from 1 to 5, let's say, right? So let's say the data looks like this. In sequence, it looks like 1, 1, there's a 2 in there out of 10 people, let's say. And then there's a 3, 3, 3, 3, 3, 4, 4. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then a 5. So I think that's a pretty accurate what you might see, right? There's probably 2 people who don't really like bananas that much, a bunch of people who think it's, mid, a little bit better than mid, and then some banana fanboys. So mode, mean, let's move this up here maybe. So taking this as an example here, the mode, the most frequently occurring data point would be 3, right? You can see here, 3 is the most frequently occurring data point. There are 5 people who rated the banana as being a 3 on the scale, right? And that's way more than the only other highest, which would be 2, right? 4 recurs 2 times, or recurs once, right? Occurs 2 times, recurs once, right? Then the rest are singular. So, right, 5 3s is the most frequently occurring data point. And that would be 5. Or sorry, what am I saying? 3. Jesus. So, the mean is the average. A lot of people will call it the average. AKA the average. This is, if you don't know math, the average is when you add everything up and then divide by the number of numbers, basically. So in this case, the number of scores, right? So yeah, I add up all the data points and divide by the number of scores. So add up. We'll write it nicely. Sum of all data points divided by number of data points. Huh? Bye-bye. Okay. Alright, yeah, I have one in my bag as well, no worries. Love you. Sorry, I was just saying bye to my mom. She's picking my sister up. So, the mean, the average, the sum of all data points divided by the number of data points. Sum means everything added together, right? So, how do we calculate that? We take out a calculator. There we go. Whoa, that's a bit big. So, we have all of our data points here. We have 1 plus 2 plus 3 plus 3 plus 3 plus 3 plus 3 plus 4 plus 5, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there's another 4. My bad. Plus 4. 31. Right? 1, 3, 6, 9, 12, 15, 18, 22, 26, 31. Yeah. So we have 31 divided by 10. I believe that will be 3.1 if I'm not an idiot. Yeah, 3.1. So look at that. You see how these are similar? In some cases, you know, it might not be similar, right? If there was, for example, if it was a way bigger pool of data, right? Or if it was a way bigger scale and it was like 1 to 10, and say you had a bunch of people rate a banana as 1, like say 5 people, right? If you had 5 people rate the banana as 1, but then the other 5 were like 7, 8, 9, you know, 10, 10, 10 or whatever, then the average would be way higher than 1, just by 1 being the most frequent, right? So that's where things get a little bit off. Same with median. The median can also be off. So the median, did I put this? No, I didn't. Okay. Yeah, the median, might as well put space. So the median, take on the calculator. The middle value when the data points are put in rank order from smallest to greatest. It's from smallest to greatest, not greatest. As you can see here, I already did that because I knew this was coming. Put in rank order from smallest to greatest. It can also be greatest to smallest, either way. All of the, as long as it's ascending or descending, like as long as it's in sequence, all of the data must be used, even if some of the scores are the same. If there is an even number of data points, the 2 middle scores are added together and divided by 2. So basically, we just take the middle value. This is an even number of data points, right? So we don't have, if it's an odd number, then you have a number in the middle that you take, and that's just the median, right? But if you have an even number, sorry, I'm burping a lot. Okay. I'm doing it silently. If it's an even number, then you have to take the 2 variables, obviously, and then you get the average of the 2 variables. Average of 3 and 3 is 3, obviously. So the quote-unquote middle value, take all data taking all data points in sequence, the middle value slash average of the 2. For this for odd numbers, and this for even numbers, right? So middle value, taking all points in sequence, the middle value if it's odd, or the average of the 2 middle values if it's even. So what is it here? It is 3, because you add 3 together. Is it these 3s? Yeah, these 3s. You add 3 plus 3, 6, divide by 2, because there's 2 data points that you're taking into account, and there you go, you get 3 again. And look at that, they're all pretty similar, but in other cases they might be different. So let's go over, we can look at the examples as well. If you did all the, if you learned about all the studies already. So Andrade and Doodling calculated the mean number of correct names recalled in a surprise memory test. So that's the mean, right, the average. Pilyevin et al. Calculated the median number of seconds that passed before help was offered. And the mode Hassett et al. Tallied whether the male and female monkeys chose to play with the wheeled toys or the plush toys. The mode could be used to demonstrate which type of toy was favored by each sex. So, yeah, in this case, when it's binary, mode is obviously useful, because there's only one of 2. There's only, you can only choose one of 2 choices, and so there it's choosing which one is more frequent is obviously gonna end up being which one is more preferred, right? But in most cases, when it comes to quantitative data, you're usually gonna see mean, and very rarely you'll see median or mode. Because mean is just the most accurate, right? That's why, yeah, as you can see, it's in decimal form. Obviously, it can just be an integer, but most of the time, if it's a large sum of data, then, or if it's a lot of different data points, then it'll be a decimal, and the mean is the most accurate. Like, this is exactly the average, right? Or this is like the kind of assumed average, and same with this, right? These are just kind of like guesses, and this is exactly what it is. Okay, so now we go on to measures of spread. Measures of spread help researchers to identify how similar the data points are to one another, give an idea of the amount of variation in a data set. Help identify similarity of data. Similarity slash variation. In data rather than in data points or of data points. Yeah, in an experiment, the means of both the experimental and control groups might be very similar, but this tells us nothing about how diverse the scores are. In one group, some of the scores might be very high compared with the mean, and others might be very low. In the other group, the scores might be all very close to the mean. There are various measures of spread, and the two you need to know about are the range and standard deviation. So, let's go over those. Range and standard deviation. I guess actually like this. So, range tells us how widely the data is spread between the lowest and highest data points. The larger the range, the wider the data is spread. Can be used with a median or mean. Let's write that down. How widely the data is between highest, lowest data points. And then how to calculate it, you take the highest value in the set of scores and the lowest value and subtract the lowest value from the highest value. So lowest value minus highest value. It's here. We'll do this as well. Okay. Actually, since I'm using other stuff for it, it's better to just do this. Okay. So lowest value minus the highest value. So the range in this, the range here, if we take this again, we take this again, the range would equal 5. Sorry, I'm retarded. Wait, is it really lowest minus highest? Oh my god, I'm brain dead. Don't even look at me. Don't even laugh. Don't laugh. Don't laugh at me. Don't do it. I know you're laughing. Stop. Stop laughing right now. Stop laughing, okay? I don't take math. Subtract the lowest value from the highest value. So, like this, highest value minus lowest value. Once I got -4, I realized something was up. So yeah, we get 5 minus 1, which is 4. So 4 is our range. The range of this is 4, because it's 5 to 1, right? Alright, and then we have standard deviation. This one is where it gets a little bit more complicated. So, this gives precise information about the spread around the mean. Smaller standard deviations suggest the data points are clustered more tightly around the mean, and larger standard deviations suggest that the data points are more diverse. Precise. How did data is spread around the mean. High standard. I'm gonna write STD for standard deviation. Okay. Or actually, they write SD, I think. So I'll mind. So high standard deviation equals high spread and vice versa. Okay. So, the calculation. The mean is subtracted from each data point to see how far each score deviates from the mean. The rest of the calculation allows the researcher to identify the average amount of deviation from the mean. Thankfully, you don't actually have to know how to do it, but let's just do it anyway. Standard deviation calculator. We have that, we got that. Calculate. Bro, that is crazy. Why they gotta be so crazy right now? That's so much. Look at all those calculations, dog. That is so fucked up. Man, that shit, math is so fucked up, bro. Goddamn. Our standard deviation is 1.04. I think that's low. Wait, I don't know. How to interpret. Whoa, they're reading my mind. But like, what's high and low though? Is one low? Oh my god, I can't type standard deviation. Ah, okay. It means that on average they're 1 unit away. Ah, okay. Alright. Do you see this, guys? Do you see this? So, the number that's representing your standard deviation, so in this case, what was it, 1.07 or something? It was like 1.07, right? So 1.07 is our standard deviation here for this, which means that on average, a data point is 1.07 away from our mean, which is 3.1. Right? We'll just write here. Very complex calculation. So, but it's 1.07. It's plus minus 1.07, right? Is how you're supposed to write it. I don't know. Wait. Wonder if I can find the plus minus symbol here. Did they have it? Whoa. Hey, what? Oh. They didn't have a plus or minus, but it's supposed to be like this, right? Plus minus 1.07, which means that on average, a data point is plus or minus 1.07 units, so 1.07 of rating of banana away from 3.1, which is our mean. That's what it means. And that's how you interpret it, is that you have to interpret it based on the context, as we saw before. Over here. Oh, it doesn't let us get to it, does it? Yeah, it doesn't. But yeah. I don't know if you saw it, but basically, the number it's proportional, like it's relative to the data set, like the size of the data set, or like how the range of the data set, right? So like plus minus 1.07 here for standard deviation is moderate, right? Because if we think about it, 1 is 20% of our scale, right? Compared to if it was plus or minus 1 out of a scale from 1 to 100, then the standard deviation is points are only deviating on average, 1% of the scale away from our average, right? Sort of thing. So that's how you kind of figure it out. Okay, next. We're done there, I think, right? Yeah. This is the end of the chapter, I think, isn't it? Yes, it is. So, bar charts, histograms, and scatter graphs. Let's do some enters. We can see stuff here. Allow for communication of results visually. Easier understanding of so the bar chart. The bar charts. Bar charts are very helpful for quickly demonstrating the relative difference between the values obtained from two or more groups or conditions in an experiment. Often bar charts compare the mean, median, or modal values obtained in two or more levels of the independent variable in experimental studies, but they can also be used to illustrate quantitative data from observational and self-report studies. As we see here, this is a high empathy, low empathy group. Percentage distance from the center of the room. If you don't remember this study, it's just the preferred interpersonal distance study, and you can see high empathy people on oxytocin had the least, the lowest PID, while the effect was the opposite for people with low empathy. Their preferred interpersonal distance went up. Their PID went up when they took oxytocin. So, we might be able to make something similar here, where we can have this again, and then this can be sober. And let's say baked, and then what's a good food for this? It's a good food to represent high versus sober taste. I don't know. I mean, weed is illegal in Japan. Not that I would have ever ingested THC before, guys. Sober. I actually haven't. Versus baked. Or let's just say high in case people don't understand what that means. Or let's be nice. Let's say sober versus drunk. What do people like to eat when they're drunk? Pizza. Why not? Pizza. Pizza sober versus pizza drunk. So, I assume this would be similar for being high, actually. And actually, high would make it better. So, let's see. Let's write high. So, when you're high. We'll write baked so that it matches. When you're baked. Okay. Let's say, it ends up looking more like this. 3, 3, 4, 4, 4, 5, 5, and the rest are 5s. 5, 5, right? So this is 2. Nobody's gonna rate pizza 1. Who cares how sober you are, how straight edge you are? Nobody is rating pizza a 1. Like, get out of here. So, for the bar chart, what we could do actually, make a bar chart maker. Not Canva, bro. That shit is so cancer, dude. Nobody likes Canva. Yeah, vertical, normal, data, number of items, 10. Wait, what am I saying? 2. Sober versus baked. Value. The value, let's put these into a mean calculator. The mean 3.2. Sober probably looks like this. I think this is a good representation of what sober looks like, and of course baked looks like it's a good color for baked. I think that's pretty representative. While baked, our mean is 4.3. So series details, number of items. I think the name would be pizza rating. Labels. Oh no, this is just the name of the. Maybe that's fine. I don't know. Pizza rating. Maybe they would do. This is kind of taking 1,000 years too long, bro. Oh, but we have it already. Oh, perfect. It already worked. Okay, so you can see here. This is what the bar chart would look like, right? We have our pizza taste rating. Oh, I see the issue. Series details, pizza taste rating. Delete that. There you go. Series 1. Why is it doing that though? There should be multiple of these. Am I dumb? Okay, whatever, it's fine. Yeah, you can see here, this is what the bar chart would look like, right? This is what the bar chart would look like. So, back to useful things. There was literally one right here, but I wanted to use this like a similar thing. Anyways, so quickly demonstrate relative diff between values from diff groups. Often comparing mean, mode, median. Those are supposed to be commas. I don't know what I'm doing. Then we go on to the histogram. Histograms are used when the data is continuous.
when the data is continuous.
What does that mean? Do I remember? Let's see. Continuous data is data that can be measured on an infinite scale where values can be infinitely large or infinitely tiny. A good example is time. Units can be as tiny, as large as a century, or as tiny as a century, as large as a century, or as tiny as a millionth of a nanosecond. A histogram shows the distribution of all the collected data rather than the average. The horizontal x-axis is divided into appropriate intervals, representing the full range of data, points or scores, and the vertical y-axis is labeled frequency and shows how many people scored within each interval. As the data is continuously, bars on a histogram should be touching, and if there are no scores within a certain range, a gap should be left. So let's look at a histogram example, because they don't give one. So basically, technically our rating thing where's a good one? Here you go. This is easier. So we could do something similar, right, with our pizza thing. If we took one of these out of the equation, right? Let's just delete this. But if we took one of those out of the equation, for example, and if we just look at this, the banana one, then technically you could have the number of students on the number of raters on the y-axis, and the score from 1, 2, 3, 4, 5 down here, 1, 2, 3, 4, 5, right? Remove this, and then we would have here for 1 it would be 1, like over here. For 2 it'd be same thing over here. For 3 it would be like way up here or whatever, yeah, like around here. For 5, and then for 4 it's 2, so it'd be here, and for 5 it's 1, so it'd be here. And so that's what it would look like. So histogram is used for continuous data. What is continuous data? They kind of explained it in a weird way. So it's continuous versus discrete, by the way, I forgot. It's not continuous versus non-continuous. So numerical data that can take on any value within a given range. So that is a good one. So that's basically what mine is, right? That's what this is. It's data, numerical data, that can take on any value 1 to 5 within the range of 1 to 5, right? So, but this is also kind of discrete in the way that it's specific values. If it was like on a point scale, like point, but that's kind of arbitrary, kind of, right? But anyhow, yeah. Points includes action, etc. So an example would be like height, or foot size, or IQ or something like that. Okay, finally we have scatter graph. So scatter graphs are used to present correlational data. Presents correlation data. Like a histogram, they show the complete distribution of the data collected from all of the participants. We'll wrap that up here too. Shows the music stopped. Wow, it's been an hour. Baldur's Gate. Why not? Baldur's Gate 3. You should play this game. If you haven't, you should play this game. Did the same, yeah, same guy. Borislav Slavo is actually the GOAT, bro. This guy, he made the music for Divinity Sin Original 2, probably the older one as well, like Divinity Sin 1. But Divinity Original Sin 2, dude, such a good game. Gotta play this. I think I said Divinity Sin on accident. Anyways, presents correlational data. But yeah, up here shows the distribution of all the data. Not average. Same thing here. X axis it's the sorry, I'm just going back to this because I kind of missed out on some stuff. Appropriate intervals and y-axis. Y-axis would be the frequency. So x-axis is simply covariable 1. That's kind of a little bit of a voice crack, actually. And the y-axis is simply covariable 2. Covariable 2, 2, 1. Boom. It doesn't matter which covariable goes on which axis. Yes. Next, the pairs of scores obtained from each participant are plotted using a small dot or cross. Every data point plotted as a dot slash cross. And we can see here, this is a negative correlation, so we'll get into that for a second. But let's just look at a scatter graph example that's easier to see. This is a classic, isn't this? This is a classic, right? What am I doing? Why doesn't it want to zoom? Okay, we'll just click on it. Yes, ice cream, right? Yes, ice cream. It's a classic. So, example here. The local ice cream shop keeps track of how much ice cream they sell versus the noon temperature on that day. Here are the figures for the last 12 days, blah, blah, blah. So they plot each of these points, right? Because we have two covariables here. Temperature and ice cream sales. How much ice cream are they selling, and what temperature is it at the time, right, or during that day? So they plot that on this scatter plot, or whatever, and they plot it, and it looks like this. And you can kind of see a trend here. You can kind of see a trend here of going up from the bottom left up to the top right, right? And when you see something like this, that always means positive correlation. So any sort of diagonal line going from the bottom left to the top right, anything that is just angling upwards towards the right is a positive correlation, meaning that When temperature goes up, sales goes up, right? Correlation just means like relationship, if you don't know that. And then we can draw a line of best fit, which people do. Line of best fit just means a line that would be closest to like all the points or whatever, right? So, anywho, understand that. Correlation can be seen from patterns made by the from pattern of the scattered points. For example, positive correlation equals trend towards top right. Oh, it's this song. Do dee doo, down, down, down by the river. It's a classic. Okay, sorry, I'll stop. The negative correlation is a trend towards the bottom right. Here we go. Yeah, positive correlation, negative correlation, no correlation, as you can see here. No clear. Sorry, what am I writing? No correlation is no clear pattern. And there you go. That is it, guys. That is it. That's it. I'll go over it again real quick, and then that'll be the end of the video. So, data analysis. Measures of central tendency. They are descriptive statistics that summarize large sets of data points into single trends / patterns / numbers, and this allows for the easier comparison of variables. To find measures of central tendency, we have 3 different types. And using this banana rating scale from 10 different people, 10 different participants study that I made up, the mode, the most frequently occurring data point, in this case 3, because 3 occurs 5 times, nothing else occurs that many times. This is the most frequently occurring data point, therefore 3. That's the mode. The mean, which is the average, the sum of all the data points divided by the number of data points. So we add all these up, I believe it was 31, and then we divide it by the number of data points, which is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide 31 by 10, you get 3.1. And then finally the median, the median, the middle value, when taking all the data points in sequence, the middle value when it's odd, or the average of the 2 middle values when it's even. In this case, we have an even number, right? An even number of data points. So we take the 2 middle points, which are 3 and 3. The average of 3 and 3 is obviously 3. So it's 3. Genius. Next, measure of spread. Used to help identify similarity / variation in a data set. We have range, taking the same set of data. How widely the data is spread between the highest, we'll just make it like this, between the highest and lowest data points, which is the highest value minus the lowest value. Highest value 5, lowest value 1, 5 minus 1 equals 4. Boom. Then standard deviation, precise info on how data is spread around the mean. High standard deviation equals high spread, vice versa. The number itself, for example, plus or minus 1.07 here. The way to interpret it is that it is basically telling you the average distance of units a data point is away from the mean. So the mean here is 3.1. So the average distance that one of these data points is going to be away from 3.1 is plus or minus 1.07. Very complex calculations. Thankfully, you don't need to know it. You just need to know what it is, what it means, why it means, all those lovely things. And so in this case, this is kind of a moderate standard deviation, right? Because it's 1 out of a 5-point scale. That's a whole point of a distance that something is away from the average, right? On average. But for example, if it was plus 1.07 on a 100-point scale, then everything is only overall 1% away, right? And that's much less than a whole 20%, which it is in this case. So it's when trying to interpret standard deviation, you need to look at the range of data to understand and put it in context and then interpret it from there. Next, finally, graphs and charts. They allow for communication of results visually, and this usually makes it easier to understand trends and patterns in the data. Then we have a bar chart. Bar charts, I have an example here. Bar chart here. So bar charts quickly demonstrate relative differences between values from different groups, often comparing the mean, mode, or median between each other. In this case, it's not. This is just the count, but it always differs. You can find a million different ones, like for example, type of sports, number of students, whatever. Anyway, next on to histogram. Histogram compares continuous data. Continuous data is numerical data that can take on any value within a given range, for example, and it has no distinct points, and usually will like include decimals or something like that, right? For example, height, right? Height doesn't have a distinct point. People don't all fit into like 10 different types of height, right? That's not how it works. We all have completely different types of height, there's, down to the fucking molecule, right? Same with foot size or IQ or whatever. So, that's what continuous data is. And histograms, go like this, go like this as well, sorry. So, histogram shows the distribution of all the data, not the averages, but the distribution of all the data, using the x-axis, so the horizontal axis, as appropriate intervals for the data. So, for example, if it's height, maybe the intervals will be like, for like men, it'll be like 4'11", 5 foot, 5'1", whatever. That would be a pretty big list, right? But something like that, right? It might be like 5 foot, 5'3", 5'6", 5'9", 6 foot, something like that. That'll be the bottom, the x-axis as at appropriate intervals for the type of data you're using, and then the y-axis would be frequency. So it might be like frequency of men at that height, right? And so, for 5 foot, it might be, there's like only a few men, like the bars up here, whatever. Also, I forgot to add it. It's basically a bar chart design, but bars are touching, except for when an interval has no data. The bars are touching. Space slash bar. Okay. Yeah. There you go. Now you know what a histogram is. So, scatter graph, the final one. This presents correlational data showing the distribution of all the data, not the averages. The x-axis is the first covariable, and the y-axis is the second covariable. These are interchangeable. Then every data point is plotted on that graph as a dot or a cross, or whatever you like. And the correlation can then be interpreted from the pattern of the scattered points. For example, positive correlation is a trend towards the top right, starting from here, if you can see my cursor, starting from here up towards here, right? It doesn't have to be a perfect diagonal going straight up from bottom left to top right. It can be a more horizontal diagonal, one with like a less less steep, it can be really steep, it can be either like that or whatever, and that just gives you more info on what type of or how the relationship works. But either way, as long as it's bottom left to top right, is that as long as that's the trend, that's positive correlation. Opposite for negative correlation, that is a trend towards the bottom right, downward sloping. If we're talking about from left to right, it's downward sloping. Same thing. It can be less steep, more steep. It just depends. But either way, that's a negative correlation. And no correlation can be interpreted if there is no clear pattern of points. If it's just a bunch of points splotted all over the place. Splotted is not a word, but I made it up just for that. There you go. That's how much I love you guys. Good luck with your studying. Bye-bye.